Hey Global Village, what's up? Okay, today I want to have another little talk about AI and more specifically how I think humanity as a whole seems to be reacting to it. Because as I think I've alluded to in previous videos, I'm genuinely quite concerned about it. Um, Now, that is not to say that I don't believe the threat of AI is very real, but not in the sort of hyperbolic AI is going to become a super intelligent, autonomous machine that's going to enslave humanity. No, I don't mean in that way. I just mean that people like Elon Musk and Sam Altman are going to potentially find use cases for AI that serve them in terms of their personal enrichment, but don't benefit human society either socially, culturally, or economically. There are quite a number of reasons why I think we need a sort of global response to legislate exactly how AI can and can't be used. There are a litany of problems and very serious ones, but that's not what want to talk about in this particular video. So I think what I will do is I'm just going to use a little analogy to help hopefully kind of highlight the issue that I want to make here. So let's just consider for a moment a television set displaying a very realistic image on the screen. Now, we of course all know how to interpret that. We understand it's not a representation of anything that's actually real and physical happening. There's not actually a person trapped in a little box there that's talking to you. Now, however, if we were to take that image and we were to go back to a time before people had even conceived of a television set, and we played this image to them, and let's say it's a person who's like pretending they're trapped in a box and they're pressing their hands against the walls of this box and saying, please help me get out of here, help me break the screen so I can get out. The person who sees that is going to have an incredibly different reaction to what they're seeing, to what we're seeing. They will imagine something entirely different about what the reality of what they're being presented with. And I think this is a way of kind of highlighting to a degree how I think people are going very wrong, or a lot of people are going very wrong with what they are seeing or what they are manifesting and extrapolating out of the current state of the art in artificial intelligence. Now, it's not to say that AI isn't very impressive at the moment. Large language model chatbots are very impressive in terms of what they can do, but what it implies about the underlying technology and that somehow it indicates there's no ceiling there, and that it's just indicates that we're that much closer to the AI singularity. I think that is extremely problematic. And I thought I'd just kind of talk about maybe a little bit about my personal view as to why I feel very skeptical about that, because I doubt this is something that's been commonly talked about. In fact, I don't know that I've seen anyone really sort of present this kind of particular point of view. So the first thing is and I don't have any perfect answers here. I'm just kind of, I guess, using my own intuition here based on my own experience as being a software developer for my entire life, and just how I understand technology and what it is, and certainly what it isn't. So let's just first consider that if we want to compare the human brain and the way we function and think compared to these large language models, then we need to understand that they are night and day. They are incredibly different. Now, of course, these AI tools, just like every other piece of software that's ever been developed before it, sits on a platform called a von Neumann machine. Basically just a classical architecture that has not changed in any substantive way since the development of the technology. the CPU, the memory, the buses that run between them. This basic concept of a computer is how everything's being built. So the only thing that's really different here is the type of software that's being imported and loaded into the hardware architecture. That's really the big difference. Now, granted, we are using GPU architecture rather than CPU architecture to actually train these things, but that really doesn't, again, that doesn't represent a like some sort of massive breakthrough in the physical topology of the hardware. GPUs have existed for a long period of time. Really, their only significant difference from a CPU is their massive capability for parallel processing. That's what really sets them apart, and what lends them to the type of processing power you need when you're doing intensive training of these AI models. So the point being, we need to understand that this architecture is dramatically different to the architecture of a human brain. Now, consider when a human is still young and growing up, that the human brain is not yet fully developed. And one of the things we say is that, a young teenager, for example, hasn't got a fully developed frontal lobe, and that they're not always going to make great decisions because their brains just haven't fully developed yet. So that's why they need some level of guidance, why we maybe want to set certain rules about them. And of course, I'm willing to bet if most of you out there, and certainly myself included, can look back to our teenage years, like I shake my head at the unbelievably stupid shit I did when I was young. Your ability to really think things through and to make mature decisions that fully comprehend the full repercussions of what you're doing, those things just aren't there to the same degree. Now, the reason I bring that up is that it appears there is a very powerful relationship between our capacity to think and reason and the function of our brains and the physical development of our brains itself. Now, this is really not how it works with the hardware and software models that we're building these AI technologies on. The hardware and the software are two separate things, and the software can, in a certain sense, run on a range of different hardware, and the only thing that's really going to differentiate it is the raw performance. Qualitatively, it's going to be exactly the same product, no matter the variance of the hardware that you're running on, as long as it's basically compatible with it, the correct instruction set to be able to run the lines of code, etc. So it's not like the hardware is somehow evolving along with the capacity of the software itself in any qualitative sense. But that is what's happening with the human brain. And I want you to consider this. If you were to compare physically two human brains with each other, they would always be slightly different. I'm rather certain that in the entire history of humanity, you could not find two human brains that are exactly alike, right down to the very last neuron and synapse. They're all going to be structured just a little bit different. And so this speaks to there's some sort of uniqueness in the way that we develop as humans and individuals, and that our capacity to think related to our own brains is, in a certain sense, its own unique product as it evolves through our own personal lifetime, both our experiences and the physical development of the brain. Again, this is so dramatically different to what we are creating through our technology path at the moment that you have to understand there must be some profound differences about the type of AI we're creating and the sort of intelligence that we possess. And the whole term AI is itself quite problematic. I almost think it should be called EI, as an engineered intelligence rather than artificial intelligence, but that's another story. So yeah, I mean, the other thing to consider is that we use the term in AI. We use the term neural networks as kind of the fundamental breakthrough, but even that is very misleading because, as I just explained, physically there is no neural network when it comes to the architecture, the physical architecture of the hardware. It's a neural network in logical concept only, in terms of the way the logical learning mechanism has been developed to kind of emulate a neural network in a purely logical sense. There's no physical neural network there. But there is most certainly a physical neural network in our brains. So it's realized not just conceptually, but physically in the real world, an actual neural network. And as I think I mentioned in a previous video I made, we understand very little about the full capabilities and function of that physical neural network that our brains are operating in. We've taken only the crudest concept of a neural network and then logically modeled it in our AI models. But I would say it would be no better than a crude two-dimensional reflection of the real thing, and likely missing some dramatically important and qualitative concepts about how our brains actually function, both in terms of how we think and how it relates to the physical architecture in our brains. So all this is to say that I think there's just a massive gulf that we have not yet discovered, that we need to discover before we can really start talking about whether AI can become sentient, whether it can become autonomous, whether it can have a sense of self, things that I have referred to in my previous videos. There's no evidence at all that these things have any sense of self, and simply parroting and being trained to behave in ways that appear to be human-like in their responses and behaviors. This is not evidence that any such thing is happening, any more than it's evidence that there's an actual person trapped in that television set trying to get out of it. Anyway, this is all just a little bit of food for thought, and it's a little bit why I'm trying to just push back on a lot of the popular narrative that seems to be coming out now, and even a lot of like so-called experts are kind of not really pushing back against in a way that I would kind of hope that we'd be hearing a little bit more of. Anyway, Bendy out.